Hello everyone, my name is Shuying Wang from the Central South University, China. Thanks a lot for the Symposium organization committee giving me this wonderful online communication chance. It's my great honor to be present my recent research progress on soil conditioning for earth pressure balance shear tunneling. The presentation title is the effect of bentonite slurry on functions of form for changing the permeability characteristics of the sand. This presentation includes three sections. First one is research background, and then testing approach and results. Finally, conclusions. Let's see the research background first. Metro is developing faster in China. It has exceeded over 7,000 kilometers in length by the end of the last year. There will be more than 4,000 kilometers long metro line to be built by 2015, according to the current planning. A shared tunneling is a major method for urban rail transit tunnel construction. The application length of shared tunneling is estimated to exceed 70% in urban rail transit tunneling mainland China. EPB shared tunneling is more popular due to the low engineering cost and the environmental influence. We know that geological conditions influence the EPB shared tunneling a lot. Water spilling easily happens at the outlet of the screw sphere during the EPB tunneling in the sandy ground and water, causing larger ground sediment because of poor sand water bodies. In the clay ground, clay clogging easily happens, reducing advancing rate because of its limitations on cut head and cutters. However, in city ground, shear can be advanced smoothly. Soil conditioning is very important for EPB shear tunneling. This presentation focuses on how to do soil conditioning for EPB shear tunneling in sandy ground and water. To control the water spilling, some agencies were injected before the cut head into a shear chamber and screw wheel for conditioning mark. Common conditioning agents include foam, bentonite, slurry, a polymer extra. The foam has the following functions. Due to the lubrications, it can improve the fluidity of the foam. It can decrease the permeability of the mark. It has high compressibility, so it can reduce the pressure change in the chamber. It can increase the porosity and decrease the shear strength of the mark. In the sandy ground and high water pressure, foam is not enough to condition mark for the EPB shear. Other agencies should be such as the bentonite slurry. Some bentonite slurry should be used. Bentonite slurry has these functions. It has a high viscosity. It can enhance the water retention of the mark. It can provide the fine particles adjust the gradation. It can stabilize the foam particles. The control in the permeability of mark in chamber and screw wheel is very important for smooth advancing of the EPB shared in sandy ground and water. There has been some research findings on the effect on the sand permeability. However, the research is still limited on the permeability characters of the formed bentonite slurry conditioned sand, especially interaction between the foam bubbles and fine particles. Okay, let's see the testing approach and results. A poorly graded sand was tested. Here are index properties of the sand. A formed agent with a weight concentration of 3% was used to generate foam. Is chemical compositions I showed here. This foam generator was used for generating foam. This element was is very similar to that used in EPB shared. For promoting conditioned effect, sodium bentonite was used to make a slurry with a weight concentrated action of 7%. To conduct a permeability test, we mixed the sand with a water content of 10% first. Then the wet sand was mixed with the bentonite slurry. Finally, the foam was added. The permeability test was conducted on conditioned sand in this safe designed large-scale permeameters. Here are the testing conditions. The maximum hydraulic static pressure head was 9.6 meters, and the maximum hydraulic gradient was as high as 17. Normally, for EPB shared tunnels in cities, the hydraulic gradient in the chamber mark is in the range of 2 to 5. However, one undergoing EPB shared tunneling project caused as Longquan water tunnel in Kunming Channel has a maximum hydraulic gradient larger than 10 in the chamber mark. Thus, it is necessary to study permeability characteristic and hide hydraulic gradients. Slump test was used to investigate the workability of the conditioned sand. You can see that the water and the foam bleeding happened, right? For the sand conditioned without bentonite slurry. However, with the additions of the bentonite slurry, no water and bleeding happened, and the conditioned soils show the excellent workability. In the right, the slump values increase with foam injection ratio. Low bentonite slurry injection ratios decrease the slump value of foam conditioned sand, but a higher bentonite slurry injection ratio is no less right, because with higher bentonite slurry injection ratio, the slump value will increase. So the reason is that if the bentonite slurry injection ratio greatly increase, excess bentonite slurry dominates of the conditioned sand and reduce the shear strength more. Here is the permeability curve showing the variation permeability coefficient against the time and different hydraulic pressure heads. Generally, the permeability coefficient will increase the time, right? However, when we have in deeper investigation on their early stage, different phenomena will be found. In the low hydrostatic pressure level, the permeability coefficients showed a little reduction, right? Some here. The reason showed a little reduction, right, at the early stage of permeability test. The reason is that under the hydrodynamic actions form bubbles and bentonite particles constantly adjust their position in the soil skeleton to form the most effective water block structure. However, generally the permeability of condition sand experiences three stages. First one, initial stable period. The permeability coefficient condition sand maintained low levels at the beginning. The initial permeability coefficients and its durations has a significant influence for the EPB shear tunneling. Second, the faster growth period, the permeability coefficient increase rapidly. The third is the slowed growth period. The growth rate of permeability coefficient slowing down, and the permeability coefficient tended to be close to that condition and condition sand finally. With the sand water content and foam injection ratio, the bentonite slurry significantly reduce the growth rate of the initial permeability coefficient and obviously extend the duration of initial stable period. However, as the hydraulic gradient increase, the initial permeability increase rapidly, and the duration become shorter and even disappeared, right? Bentonite slurry reduced the permeability coefficient in the slow period. Since the bentonite particle block permeation, the channel the pores, the hydraulic gradient, the lower the permeability coefficient in the slow growth period. Thus, with increased time, the permeability coefficient didn't increase to that of unconditioned soil. The reason is that the process of increasing hydraulic gradient also caused migration of fine particle, which may be trapped downstream of the soil specimen. Additionally, as the hydraulic gradient increase, a seepage-induced consolidation process occurred in the soil with high compressibility. With these figures, it is clear to find that with addition of bentonite slurry, the permeability coefficients of conditioned sand decreased, right? Decreased significant, and duration low permeability coefficient was extended. In the form condition sand, the air in the small bentonite enters the large bubbles through the formed film, and then formed crossing occurs. With additional bentonite slurry, the form the fine bentonite particle forms steric barriers to limit liquid film's drainage, prevent the foam from the crossing or dispensing. Additionally, we can study mechanism of stabilize forms by the bentonite particle from the perspective of particle detection energy and capillary pressure. On one hand, the particle detachment energy is related to the free energy involved into move the absorbed particle from the foam film. With higher delta G, with higher particle detachment energy, it's more difficult to remove the absorbed particle from the foam film. From left equation, when the contact angles theta and radius I of the particle decrease, the particle detachment energy decrease. Thus, is more benefit for the draining of foam and liquid and the contacting between the formed bubbles. On the other hand, the stabilizer of foam also depending on the capillary pressure between the bubbles. The maximum capillary pressure can be calculated with this equation. When the contacting angles theta and the radius of I of the soil particle decrease, the maximum capillary pressure increase, indicating more difficulty to in the drainage of foam liquid and the contacting between the foam bubbles. Thus, to consider these two styles, optimal contacting angle should be related. Capture presented the optimal contact pressure for particles stabilized formed bubbles is merely distributed in the range of from 70 to 110 degrees. It's noted that contact pressure, contact angles bentonite is about 71 degrees. Thus, this is why with the additions of bentonite slurry, the permeability coefficient of conditioned sand decrease and maintain a low value for a longer time. Okay, let's make conclusion. The bentonite slurry injection ratio should note to hide for the sand conditioning during the EPB shader tunneling in the sand ground. The permeability coefficients had a short decrease process during the early stage of permeability. As the hydraulic gradient decrease, the conditioned sand quickly passed through the initial stable period, and then it entered the fast growth period and the slow growth period early. With a higher hydraulic gradient, the permeability coefficients in the slow period decrease. Mainly because the fine bentonite particle migrate downwards and the speech force. The stabilized mechanism of form bubbles by the particles were discussed with two exceeding series, and the bentonite particle can be suitable options to stable form bubbles for the sand conditioning. Okay, this is my presentation. Thanks a lot. Any questions?